Okay, ladies and gentlemen, we're going to look at lesson 419, when and why do we write quadratic equations? So our warm-up, it says the expression 12t plus 250 represents the cost to purchase the tickets for a play, where t is the number of tickets. I'm going to underline that. Be prepared to explain your response to each question. So a family paid $62.50 for tickets. How many tickets were bought? Well, what I'm going to do is write an equation. So I'm going to write the equation 12t plus $2.50 equals $62.50. Then I'm going to solve the equation by working backwards. So I'm going to subtract 250 from both sides. And I get 12t is equal to 62.50 minus 250 is $60. And then 12 times t equals $60. I undo that by dividing. And I get t is equal to 5. So I'm going to answer my question and put 5 tickets. So a second question, a teacher paid $278.50 for tickets for students. How many tickets were bought? Again, I'm going to write an equation to solve that. 12t plus 250 equals 278.50. I'm going to subtract 250 from both sides. And I get 12t is equal to I did that subtraction, and it's 276. And then divide by 12. I'm going to continue my work over there. It's equals, and 276 divided by 12 is 23. So our answer is 23 tickets. So now we're going to look at flying potatoes again. So the other day you saw an equation that defines the height of a potato as a function of the time it was launched from a mechanical device. Here's a different function modeling the height of the potato in feet, t seconds after being fired. So again, t is our variable and it's measured in second, and h is going to be height in feet. So what equation will we solve to find the time at which the potato hits the ground? Well, the ground would be 0 feet. So it would be 0 equals negative 16t squared plus 80t plus 64. Now, we had methods for solving equations in factored form, but not in standard form. We haven't learned a method to solve this yet. So it says use any method except graphing to find a solution. So what I'm going to do is use guess and check methods. So I'm just going to type in negative 16 and then times, I'm going to guess just 4 and then square that and then plus 80 times 4 and then plus 64. And I see at 4 seconds it's at 132 feet. So I'm just going to maybe guess 5 seconds. So instead of typing this all in, I can hit second and then enter, and then just go back and change my 4 to a 5 and my other 4 to a 5. So I'm just substituting in 5 for t and 80 times 5 and seeing what I get. And I see that it's down to 69 feet. So I'm just going to guess maybe 6 now. And I see at 6, it's actually below the ground, which is outside of our math model. So I can see that maybe it hits the ground somewhere between 5 and 6 seconds. So now I'm just going to guess decimal numbers. So I'm going to split that difference and say, well, maybe what if it's 5.5? So negative 16 times 5.5 squared plus 81 times 5.5 and then plus 64. And I got 25.5. So 5.5 is a little bit too small, and maybe it's between there. So I'm going to guess 5.75 because it's somewhere in between 5.5 and 6. So I'm going to go negative 16 times 5.75 squared plus 81 times 5.75 and then plus 64. And I got about 0.75 feet. That's pretty close to the ground. So I'm just going to put about 5.75 seconds. And then we use guess and check. And obviously that's not ideal. We're going to learn more methods for solving that later. So now we're going to talk about the revenue from ticket sales. Again, the revenue is the total money coming in from ticket sales. So we have an expression, P times 200 minus 5P, which again, we can see that expression is in factored form. And then that equals negative 5P squared plus 200P, and that is in standard form. And they define the same function. So the function models the revenue at a school that they could earn from selling raffle tickets for P dollars each. So at what price would the school collect $0 from revenue sales? Explain. Well, what I'm going to do is take that equation in factored form and set it equal to 0. So I'm going to get P times 200 minus 5P equals 0. And then we talked about the zero product property where we can set both factors equal to 0. So we could say, well, if we're multiplying two things and they become 0, either P is equal to 0, so one of our products could be 0, or we could say 200 minus 5P equals 0. And then we could solve this equation for P. So I'm going to minus 200 here. And then I would get negative 5P equals negative 200. Then I'm going to divide both sides by negative 5. And I get P is equal to 40. So we have two prices to answer our question. $0 would bring in $0 in revenue, and $40 would bring in $0 in revenue. So the school staff noticed that there are two prices that would result in a revenue of $500. How would you find out what those two prices are? So what we could do is maybe try an equation. So we have P times 200 minus 5P is equal to $500. And we could try to solve for that, but we don't have methods. Or we could actually try to solve the other equation too and say negative 5P squared plus 200P equals 500. We don't know how to solve that. So what I'm going to do is use a graph. So in using the graph, I'm going to put in the equation x times 200 minus 5x. And then what I'm going to do is graph that. Now I notice the graph shoots up and I'm going to have to adjust my window, remembering that we go on the x-axis from $0 to $40. So I'm going to change my x minimum to be 0 and my x maximum to be 40. And then I know my revenue could go to 500. So I'm going to guess maybe and I put in 400. Let me put 40. And then maybe for a scale, I don't need to count by ones. I'm going to count by fives. So again, the x scale is going to have, I'm going to go from 0 to 40 and be counting by fives. The y min, I'm going to put 0. The minimum revenue is 0. I'm going to guess maybe for the max, it's going to be about 1,000. And for the y scale, I'm going to have it count by 100. And then just see what happens when I graph. And I can see again, I'm not capturing my total graph. So what I'm going to do is adjust my window and maybe guess 1,500. And then graph again. And again, I can see I'm not completely in the right window. So I'm going to graph again and guess that maybe that's 2,000. And then you can see that I capture the entire parabola. And now what I'm going to do is use the trace function to see, well, where's a y value around 500? And we can see we got pretty close there at about 2.72. So I said use a graph to figure out, and I said at P equals about 2.72, gave me $500 in revenue. And then I'm going to go over to the other side of the parabola. And try to answer the exact same question. And the price seems to be about $37.27. Okay, that's all for today.